Hello everyone, today I will present a paper with the title Addressing the Structural Problem for Iterative Convergent Parallels Machine Learning. This paper appeared on XOCC in 2016. I want to start with a couple definitions and a brief summary of this talk. First, I want to define what a worker is. A worker is a single flex on a machine, and every machine starts a worker for every code that it has. The first point I want to make, which you might have suggested from the title of this talk, is that the schedulers are bad. Schedulers actually which are workers or machines that run slower than other workers and have a very negative effect on runtime. In this paper, they propose a system called flexible rapid assignment, which combines flexible uh, consistency bounds and temporary work setting to adjust the scheduler. I will describe flex RRs in details and the concept of helper groups, which are very important for flex RR to operate efficiently at scale. Lastly, I will show the results across a number of different kinds of clusters, demonstrating the effectiveness of flex RR. As defined earlier, schedulers are workers which fall behind other workers. Schedulers can occur for a number of different reasons. Some transient causes of scheduler include garbage collections, resource contentions, and objective function computations. Long-term causes Long-term causes of schedulers include unbalanced data distribution and load imbalance, to name a few. As the level of parallelism grew, so does the likelihoods and the magnitudes of the schedulers. There have been several prior attempts to address the problems of scheduler in big data. Some of the existing solutions include eliminating the the schedulers performance variation and blacklisting or the speculative executions. However, these solutions are not effective for iterative machine learning. Eliminating all resources of the performance variations is effective. However, it is difficult and sometimes impossible to accomplish, especially when using a public cloud computing cluster. Blacklisting, where machines that are falling behind are eliminated, end up killing the nodes, which are experienced transient schedulers. Speculative executions, where identical jobs are started on multiple workers in a race to finish first, is not suitable for iterative machine learning because some incorrect behaviors redundant words can cause, and it is too and it wastes the resource. So they came up with a new approach, which they call the flex RR. For these techniques, they combine the flexible consistency bound of XSP and a specialized form of temporary work settings. As shown in these diagrams, the, the goal of flex RRs is to design the works in such a way that all workers run as evenly as possible. So, eliminating stragglers. Actually, rapid reassignment jobs designed from the faster workers to a slower workers to progress all the workers so that no worker can get stuck at a barrier. However, there are several problems that need to be resolved in order to perform efficient work reassignment, and they call it rapid reassignment. As you remember from the earlier in this presentation, every worker preloads the input data that is going to be working on into the memory to avoid the expensive disk list. So the workers that is providing help, and we also need to have the appropriate data preloaded into the memories in order to help others. The workers will also need to coordinate each others about who help who, and make sure that all work is performed once. While at small scale, it is possible to have all workers load all the input data and perform all-to-all communication. Actually, will not be possible or efficient at larger scale. And the most important techniques they propose is the helper groups. Similar to an overlay network, workers exchange progress reports and offloaded work with only a few other workers. Each worker have a unique set of helpers who are eligible to provide help to the workers which is eligible to help. The workers preload the input data of the worker they want to help, and then it can avoid having to read the input data from the disk at runtimes, and it can improve the efficiencies. The workers groups allows for limited peer-to-peer communications, and then it eliminated the need for central arbiters. Now it's time to examine the, the effectiveness of FlexRRs. These experiments, uh, this experiments consists of two different classes of EC2 machines learning the MF applications. They show the results for BXP, XXPs with a slack of 1 and RR slacks. The y-axis shows time per iterations, and the x-axis shows the two different classes of machines, with C4's X-large machines being the cheaper and slower one. On the the lower class of machines, FlexRR had an improvement of 53% and 49% on the higher class machines. The improvement on the C4's X-large machines was greater because they experienced more transient staggerer effects. In this paper, they propose FlexRR to solve the staggerer problems by combining flexible consistencies rapid reassignment helper groups. It achieves 55 to 45% to 53% improvement in machine learning application. That's all the presentation. Thank you.